What is climate change? Well, by definition, it's any change in the climate, right? We often talk about or hear about global warming, but I'd like you to think about it instead as climate change, because if we talk about a particular region of the U.S. having a very bad winter, all of a sudden everyone decides that there's no problem with global warming. Well, that couldn't be further from the truth. We look at climate change, meaning that in some areas temperatures will go up, in some areas temperatures will go down, but they will certainly differ from what is historically most common in that area. So we look at over the past 100 years, a 0.8 Celsius increase in temperature. 0.6 of that has just been in the last 30 years, and we're looking at probably by the end of the 21st century up to a 4.5 degree Celsius temperature change. Many of you are probably saying, well, 0.8 degrees Celsius, who cares? But think about it, 0.8 degrees Celsius, roughly 1 degree Fahrenheit, we're dealing with enough that ice melts, right? So we go from icebergs to water at a very small temperature range, right? So that's why we talk about global warming, or, as we said, climate change, being most evident in the Arctic. So changes in the average temperatures. So this is taking the average temperature between 1951 and 1980. So take that average temperature. And now what we're going to do is say, all right, let's look at the average temperature now between 2000 and 2005. So point A, we're going to compare to point B. And what we want to know is the average temperature for B, 2000 to 2005, greater or less than the temperature from point A, 1951 to 1980. And what you see is all of the red and orange and dark red is all in positive increase in temperature, meaning that B is warmer than A. It's been warmer recently than it was historically. Okay, the white indicates essentially no temperature change. You see that primarily over the oceans, right? So what you have to think about is, why would we see such warm temperatures, particularly, look at this. The North Pole, northern Canada, U.S., northern Russia, experiencing some of the greatest temperature changes that we see. A 2 degree temperature change. This is Celsius now, remember. Okay, degrees Celsius. 2 degree temperature change between point A and point B on our deviations. So a 2 degree Celsius temperature change, roughly 4.5 or 5 degrees Fahrenheit, certainly enough to melt everything that would be ice in those areas, right? So what we see, if we look at Glacier National Park in Alaska, in particular focusing on the Grinell Glacier, in 1938, you see this is all glacier. It's all ice, this whole thing, okay? In 1981, it's got a nice little pond. In 2005, it's got a lake now, right? This is fairly significant changes in that ice cover. And you've lost all the ice that's on the side of this little shelf here, all that went up the mountainside here. But who cares? Well, we have to think about what a change in ice cover does to an area. Areas are dependent on the melt of snow and ice to supply fresh water to not only humans, but to the organisms that live there. With these significant changes that we don't see the return of icebergs from year to year, and the glaciers are disappearing, we lose that freshwater availability. The other problem is what we call the albedo effect. Albedo is what makes you squint your eyes when you go outside in the wintertime and there's a lot of snow. Okay, or if you've ever spent any time on the water, the reflection of sunlight from those surfaces. What we want is the sunlight to reflect. If you are a big brown mountain, you're going to absorb all kinds of heat, right, and hold it. Think about the parking lot. Walk out in the parking lot in your bare feet in the summertime. It's hot, right? It absorbs all that heat, all that radiant energy. But what we want is it to actually reflect back. We don't want it to stay in these areas. But what's happening now is with all this brown exposed, it's absorbing more heat, melting more glaciers, and the cycle continues. So what's happened? Well, we talked about CO2 and the fact that we look at atmospheric CO2 as being one of the major contributors of what we call greenhouse gases, causing increases in global temperatures, global average temperatures. We look at the atmospheric CO2 today being approximately 385 parts per million. That is up from a previous less than 300 parts per million for, a very, very long time. And we also look at high levels of methane and nitrous oxide and so on that have come in and changed the way our atmosphere is behaving, because basically what we're doing is releasing these gases, carbon dioxide, methane, nitrous oxide, all of these things, in higher levels than we used to. And by doing so, we've actually caused our planet to act like a greenhouse. So if you have a glassed-in greenhouse where we keep plants, right? You go out, even in the wintertime, if there's a nice sunny day, that space will be warm. The glass holds in that heat, right? And so what we look at with climate change and our greenhouse gases is they literally are causing the planet to hold in more heat than it should. And so we get these changes in our atmospheric conditions, which change the amount of rainfall we get. We end up changing the amount of photosynthesis that's occurring because we're changing CO2 levels. And remember, with photosynthesis, it's CO2 plus water gives you glucose, right? So we're changing that normal exchange pattern that we see, all because of these additional contributions to the atmosphere, which is basically making those gases act like a big old blanket on top of our planet, holding in the warmth. So we end up changing biomes. So biomes, remember, are ecosystems, tundra, taiga, rainforest, whatever you want to look at, but we look at it as being highly changing as a consequence of this climate change. And so the temperature and rainfall levels are what are most affected. So if temperature is up or down in an area, rainfall is up or down in an area, we can very quickly start changing biomes. And if you change biomes, the animals either have to move or adapt. So we're looking at distributions of populations being highly influenced. Populations of animals, of course, in this case, okay? We're losing species that just simply can't deal with the increase or decrease temperatures or the increase or decrease rainfall. And we're looking at changes in seasonal events. So migrations of birds, highly altered by changes in temperature and rainfall patterns. So huge issues associated with that. Many of you know the story of the polar bears. Their decrease in the amount of sea ice cover has actually taken them further away from their homes. It does not allow them to hunt properly, and they're starving, literally starving, because they don't have the sea ice. They're becoming exhausted trying to swim and look for food, and it's just not available to them. So when we look at this, this really is natural selection, right? It is who is going to survive, who is going to reproduce. But the problem being is that climate change is now affecting natural selection, whereas before it may have been something genetic, something inherited, but now we're looking at the fact that we simply can't sustain these organisms under these conditions. And so we have what we call phenotypic plasticity. So phenotype is what you look like. Those are your characteristics. Plasticity means that they're variable. So normally we see a genetic range in species. Okay, so think about the human population, think about the different phenotypes that are expressed. That's their genetic range. And normally we can deal with changes in the environment as long as they fall within that genetic range for us to deal with. But the problem is the changes in global climate are happening so fast, it means that our genetics can't keep up. So we're changing the environment and the ecosystem so fast that we can't adapt. We can't deal with the changes in the environments. And it may eventually influence humans. I say we, collective we as in animals and plants on this planet. But we do have to keep in mind that this may eventually affect humans directly. Changes in temperature and rainfall will change food availability. Changes in temperature change when organisms are trying to find mates. All of this changes, and all of a sudden, where natural selection has coordinated very carefully breeding time with food availability, now organisms are coming back, migrating back to areas earlier. Because of increased temperatures, they're getting back to places earlier. They don't have food available. So they're breeding, but there's no food to support their families.